In this video, we will solve the following system step by step, with no step skipped. We want positive integers, a, b, c such that a plus b plus c equals 12, ab plus bc plus c a equals 44, and abc equals 48. We will use the idea of building a monic cubic polynomial whose roots are a, b, and c. If a, b, and c are roots of a monic cubic, then by Vieta's formulas the polynomial is x cubed minus the sum times x squared plus the sum of pairwise products times x minus the product equals 0. Substitute the given values to get our exact cubic equation. Now, we find integer roots using the rational root theorem. Possible integer roots are plus or minus divisors of 48. That is 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. We test small positive candidates first because a, b, c are positive. Compute f of 1. 1 minus 12 plus 44 minus 48 equals negative 15, not 0. Now compute f of 2. 2 cubed is 8, minus 12 times 2 squared is minus 48, plus 44 times 2 is plus 88, minus 48 gives 0. So x equals 2 is a root. We factor out x minus 2 using synthetic division. Write the coefficients. 1, negative 12, 44, negative 48. Bring down the 1. Multiply 1 by 2 to get 2, add to negative 12 to get negative 10. Multiply negative 10 by 2 to get negative 20, add to 44 to get 24. Multiply 24 by 2 to get 48, add to negative 48 to get 0 remainder. So the quotient is x squared minus 10x plus 24. Now solve x squared minus 10x plus 24 equals 0. We need two numbers that multiply to 24 and add to 10. List factor pairs of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Only 4 and 6 add to 10. Therefore, the quadratic factors as left parenthesis x minus 4 right parenthesis times left parenthesis x minus 6 right parenthesis equals 0. So the remaining roots are x equals 4 and x equals 6, together with the root x equals 2 that we already found. The three roots are 2, 4, and 6. Since a, b, and c are the roots, the solution set of positive integers is a, b, c equals 2 for 6 in some order. We can present the triple as 2, 4, 6. We verify each original equation explicitly. Sum check. 2 plus 4 plus 6 equals 12. Pairwise products. 2 times 4 plus 4 times 6 plus 6 times 2 equals 8 plus 24 plus 12, which equals 44. Product check. 2 times 4 times 6 equals 48. All conditions are satisfied. Final answer. The positive integer triple is 2, 4, and 6 in any order. We use Vieta's formulas to build a cubic, rational root theorem to find a root, synthetic division to reduce to a quadratic, then factored the quadratic, and verified all conditions step by step.